Assalamualaikum and good evening, everyone. Thank you for joining our discussion today. Today, we will discuss about our previous career talk held on 6 November 2020. The talk was discussed about solar thermal power generation and heating, conducted by Dato IR Dr. Ali Askar Sheikh Muhammad. So let's start our discussion. Let's start with some introduction about the topic. Solar heat for industrial process, as known as SHIP, is currently at the early stages of development. Less than 20 operating solar thermal systems for process heat are reported worldwide since 2019. Most of these systems are experimental nature and are relatively small scale. However, there is a great potential for market and technological developments. In the last 2 years, the awareness for solar process heat in the industry increased and some new solar thermal systems were installed. This positive development should be supported now by further research and development in the key research questions of solar process heat. So for further discussion, I would like to have someone to share about his opinion. Please, Heidi, to share your opinion. Thank you.
Okay, thank you to Arif. So now I'm going to share about the definition of terms of solar energy of solar. So the first one is the design temperature, where we know the design temperature is the max temperature of solar thermal that can stand without damage. So the second one is the operation temperature, which is the maximum temperature of solar thermal where normal operation pursued. Okay, it also depends on the process supply and return temperature as well the number of heat exchange. So the third one is the stagnation temperature, where stagnation temperature is the temperature that reach when stagnation persists until the losses of the solar thermal equal the exhaust energy. Okay, that's all for me. Now I will pass to Muhammad Afiq.
Okay, thank you, Aidil, for the great explanation. Okay, for me, I will explain the problem it is energy basic. It is overheating. Due to overheat, for a parabolic system, overheating will have different effects and causes. During the overheating process, the absorber tubes and the whole fan cooling system are affected depending on the design temperature reached. The pumping system, which has a maximum temperature of increases in case of overheating, the rubber of other non-metallic component be destroyed. The rubber seals in the pumping system have a nominal temperature. Above this temperature, the seals will crumble and leak can appear in the system. That's all from me. I will forward to Saiful to his explanation.
Okay, thank you to Asfiq. Now I will discuss about overheating and stagnation solar thermal system. A solar thermal system overheat as soon as the operation temperature is at overheating occurs. For example, if the energy delivery by the collectors exceeds the energy demand and heat storage capacity, or if the control is leading to operation condition where higher temperatures than aimed for occur. If no precautions are taken, the collectors will either be damaged or soon reach their stagnation temperature. Still, some parts of the collector loop may still be damaged if not selected properly in accordance with the specification of the collector. There are three types, which stagnation prevention, overheating prevention, and stagnation handling. In terminology and logic of this report, stagnation prevention describes all the measures that prevent a no-flow situation from occurring. Above all, this means to ensure that even for longer power cuts, the solar loop is still operable. In practice, such a concept for stagnation prevention applies only for the short time until the solar loop can be brought to a state where either further overheating is avoided or stagnation can be allowed because it's handled and managed in a way that will cause no damage. Next, stagnation handling. Stagnation handling is necessary if stagnation is an accepted operation mode. If this is the case, then measures must be included to prevent the solar loop components from severe system damage caused by the high temperature and pressure loads caused by stagnation. And last of my point, overheating prevention. Overheating prevention is necessary if stagnation is not an accepted operation mode. If this is the case, measures must be included to prevent the solar thermal system from stagnation, avoiding the corresponding temperature and pressure stress. That's all for me. Thank you.
Continue with the overheating prevention that Afiq and Saiful explained to us. So the overheating prevention is necessary if evaporation in the solar loop is not an accepted operating mode. Operating prevention implies that the maximum temperature the solar fluid can reach is limited to a temperature quite below the corresponding evaporation temperature at the maximum system pressure that is determined by the safety valve. Overheating prevention as part of the collector concept describe system overheating can degrade heat transfer fluids, accelerate scaling, cause premature component failure, and reduce system performance. Solar thermal system incorporate safety device in the thermal loop in order to avoid this hazard. Such device normally a system level temperature limiting subsystem that add to the cost and design complexity of solar thermal system. There are different opportunities for overheating protection embedded in the collector concept. For example, mechanically using, for example, flaps or other ways of dissipating heat to the environment based on the material properties such as thermotropic absorber coating stroke 17 stroke and stroke 18 stroke. The overheating problem is especially critical in systems that incorporate high-performance collectors. As a result of its low heat losses, the IGI's honeycomb collector can reach its internal temperature of over 250 degrees Celsius. Under such circumstances, if not limited by overheating prevention. The IJI also introduced collector level overheating prevention (OPD), which enables the retention of the collector's high efficiency under normal working conditions. That's all from me. Thank you.
We are at the end of our discussion. So let's conclude what we have discussed today. Solar thermal power generation system is more efficient and cost-effective in heat storing. Additionally, this system can produce dispatchable baseload energy, which is important as it means this system produces a reliable amount of energy and can be turned on or up at will, and meeting the energy demands of industry. In addition to this, solar thermal power plants represent a type of electricity generation technology that is clearer than generating electricity and heat by using fuels. Next, someone could share conclusion to us. Haider, please.
Okay, for me, my conclusion is I think solar give us a lot of advantage. But one of the advantages is the technology development. Okay, where this technology development, where we can see in the future where it give a lot of improvement. Innovation in nanotech also can potentially increase the effectiveness of solar panel. Alright, that's my one of my suggestion. So what about Afiq?
Okay, for my opinion, okay, thank you, Eddie. For my opinion, I hope the government will use the advantage in using these energy sources because for many advantages we can have from these uses. I mean energy source such as these energy source have renewable energy. Renewable energy, we know that it can avoid energy waste and provide the energy to become better whole system. And I very hope the government will thinking about and do price stage, not the compact but price stage. Okay, that's all for me. Okay, I will forward to Saiful.
Okay, thank you, Fik. And I agree that conclusion that concluded by Haider and Afiq just now. And I'm I hope that a solar thermal system can be maximized in the future. In use must be main of the system in our country, and because we know that solar thermal system uh, has more advantage, especially for the nature. So we can, when we use uh, this solar system, that we can save our energy, and also we can save our earth. And I hope, like Afi say, I hope the government take the action to make this suggestion must be real lah, must be real, so we can face the future in good life, inshallah. So that's all from me. So thank you.
Thank you, Saiful. So about my opinion that I can summarize with the topic that we discussed. Now about 400 megawatts of electricity may grow to 2000 megawatt of electricity in 2010 and to 12,000 to 18,000 megawatts of electricity in 2020. An annual growth rate of 50% after 2020 will yield 1,600 to 2,400 terawatt hours a year by 2050. So, like Saiful said, the government must take this responsibility to make our country comparable with the other country around the world. So we can use this chance to get the achievement to our country that we love. That's all from me. Thank you.
So that's all for our discussion today. Thank you once again for having this discussion today. We hope that we have could gain more information and knowledge about this topic in further. Thank you so much, everyone. See you next time.
Okay. Yeah, well.